Welcome, everybody. My name is Dino Esposito. We talk about domain-driven design. Just a few moments ago, just before getting into the room and getting ready for the session, I checked TweetDeck, and in my stream, there was a friend of mine doing another conference in another country, and he just posted a picture of the room, of a crowded room, saying, well, there's a lot of people, there's an overflow of people willing to learn about ASP.NET, what's the next version, 5, 6, 7, whatever. The newest, wave of tools and frameworks and releases coming from Microsoft. Frankly, I'm a lot more proud of this room. Not because of you, but because the number of people you are. Domain-driven design is, humble opinion. Okay, I'm presenting about domain-driven design, but I'm writing software for the real world. And even though I don't work in large-scale enterprise applications, I work in a scenario where software has to be not particularly complex, but highly performant. And right to the point, straight to the point, because how people, operators, users, and not necessarily super smart people, engineers, normal people, has to work with that software and has to work effectively for the business, the underlying business, to run and produce money for everybody to enjoy. Domain-driven design is the best practice, methodology, approach, pick the word you like most, that I know, but I think I can extend this concept to say the best we know today, the cutting-edge approach we know today, to approach development of software in a way that at the end of the pipeline turns out to be effective. Domain-driven design is not something new. It's something that has been around, maybe ignored, but it's been around for about a decade. And over 10 years, the world in general and the world of software development has changed significantly. And probably we are only halfway in a process that will take the world to be deeply dependent on software in the years to come, even more than it is today. So essentially, many of us, at least those who have some 50 shades of gray hairs on head, we know, we may remember that in the 90s, 15, 20 years ago, it was all about having a strong, powerful machine, that server, the mythical server machine, to host a database, a powerful relational database, and everything else was a detail. Once you had a strong relational model, compliant with the first, the second, and the third normal form, with no redundancy at all, because you don't want to have redundancy, with all the relationships and constraints properly set, you were pretty much done. Everything else was a detail. You need logic, business logic, to deal with cascading updates and cascading deletions. Fine. You had storage procedures right in the database. Your company invested a lot of money to buy the database server, so most of the work must be done. I want to take advantage of that. I paid my own money, so the database has to work, not the developers. Over the years, the complexity of the logic, but also the need to, the business need of implementing more sophisticated business rules than those you could handle with TSQL in a storage procedure context, started, putting more and more tiers or layers of code on top of the database server up to building what we call today layered systems, multi-tier, multi-layer system with presentation, business, various levels of business, data access layer, and so forth. But yet, the approach, the natural, native, built-in approach that most architects use to plan software today is the approach that we inherited, maybe through education, from what was the standard 20 years ago, starting from bottom and going up. Domain-driven design played a role at first in encouraging and even strengthening this approach. So this talk is about the good and bad of domain-driven design. And more importantly, this talk will try to clear up some things that I call misconceptions. So things that you just should consider the other way around. So essentially, the same author of the inventor of the domain-driven design approach, methodology, practice, Eric Evans, he wrote a book about 10 years ago, and with that book, domain-driven design started to conquer the world. But, and this is a specific event, an anecdote that everybody knows. A little less known anecdote that still involves directly Eric Evans happened 5 years later, 2009, QCon conference, I think it was March 2009, here in London. You can still find on YouTube the video of the talk that Eric Evans gave at QCon London 2009, where essentially he said, what I have learned about DDD in 5 years. 5 years elapsed from the release of the book up to 2009. And in that talk, he essentially lays the ground for the things I call misconceptions today. So the same author observed a sort of turnaround of the perspective of domain-driven design. And the point is that today, that domain-driven design is necessary, is a strict requirement, but not because the software you write, but because it's fundamental to understand, deeply understand the business domain and what are the processes that exist in that context in the real world, and the software is there just to mirror those processes the best and the most faithful possible way. If we fail on this, if we introduce deliberately approximation, a gap, we are going to pay more and more in terms of loss of business or extra costs of maintenance, just this gap that sometimes, if we do, well, sometimes, I would say always, if we put enough effort in the preliminary analysis, we can actually spend, probably more time up front, but we save a lot money, time, and budget in the rest of the software life, and we save in terms of maintenance, in save of changes of requests, in terms of misunderstandings. So, the fundamental takeaway from this hour and a half, so the primary misconception I want to make sure that you grab and take with you when you go back to the office, is that if you today Google for domain-driven design, most of the information you find pushes an idea that doing domain-driven design is essentially building an object-oriented model where instead of using data sets, record sets, or record-related classes, you have objects instead of the customer table and something that allows you to read and write from a customer table. you have a customer class in C#, and this customer class offers properties, no properties, read-only properties, and no setters, just methods, because you have to reflect the behavior of the customer. This is the number one misconception. The real power of domain-driven design is elsewhere. And the object-oriented domain model to represent through interrelated objects the behavior of the system, that is just one possible way of implementing the results of the analysis. So the expression domain model that I'll be using quite a bit of times today, and it's, the primary expression in any DDD document, domain model should be intended as a model, a software model for the domain. So the primary misconception is associating the term, the expression domain model with a pattern or something more specific like an object-oriented model. A domain model is simply a software model for the domain. So the collection of entities, the collection of tasks, the rules that you observe in a domain. And once you have done that, then you are ready to build the software in the way that is most suitable, given the skills of the people involved, given the knowledge of the technologies, given constraints and policies for using certain technologies or not, but there is no constraint at all in that you have to do object-oriented programming when you actually implement a system. So, what's the point then of domain-driven design? The real power is not in having an object-oriented domain model, but is in the patterns and the practices it offers to perform domain analysis. So actually, we are talking about essentially the analysis as the ultimate goal of domain-driven design and where the most power of this approach lies. 10 years ago, this book, Domain-Driven Design, Eric Evans, was published, and he presented the author's vision on how to tackle complexity, to use his own words, in the heart of software. In the end, it was the real value of this book 10 years ago was that for the first time, it was offering in a well-organized and systematic way a bunch of relatively innovative guidelines for, give you a step-by-step procedure, a systematic approach to understand and design a software system. Set of essentially prescriptions. But the point that 10 years later I consider a misconception was that in the vision of 10 years ago, the part related to the analysis of the domain and building of the system, these two parts were kind of fused together. And it was not obvious where the one ends and the other one starts. So it was 10 years ago, and still today, by most authors and people who write about the DDD, it's considered a sort of an end-to-end pattern, an all or nothing. If you do domain-driven design, you end up having a complex, all-encompassing object model that fully represents the domain. And this is an old dream of any developer. I like to call it the God anti-pattern. You feel like God. You can create the world with objects. How many times we think that a certain idea we have, a certain entity we observe and recognize in the out of requirements that looks like, a class, customer, invoice, this or that. And then we immediately start thinking, yes, but I can see this class as a special case of a more general class. And this class can be, I can have a root-based class and everything that comes down of that. I can have my object class, my super object class, and everything drops out of this class in a beautiful, fantastic graph. Or if only I have time to implement this system, I will be the happiest developer in the world, and my company will be the most fantastic place to write software. It doesn't happen. It never happens. You never have the time to build such a complex system because such complex, God-like, God mode system just doesn't exist in this world. In the world, we see events, things that happen, people that do things. This is what we observe in the real world. Models are an abstraction that we use so far to try to encapsulate in a sort of a fence, okay, all the things we were observing. Today, and even more in the future, the number of tasks, actions to be performed against the software, against the user interface, and the number of events that each action generates, and an event generates other events, so the chain of events and the number of tasks is growing so big that a single all-encompassing model, the God mode approach, is just unmanageable and impractical. So the key misconception of DDD is be aware of this. Be aware of this point and stop thinking you can ever plan successfully to build a single model. DDD is not telling build a single object-oriented model for the world you see, but see exactly what is the understand what is the mechanics, what is the language being spoken in that world, and learn from that, and then figure out what is the real structure, architecturally speaking, of the system. Now, declared purpose of DDD, mitigate the burden of writing software under tough conditions. Which are these tough conditions? Huge number of business rules, complex workflows for tasks, collaborative systems in which there's a lot of concurrency, in which you are never sure about what you read and what you write. Because whatever you do, whatever you see, can change dynamically by the action of other concurrently acting users. And a new scenario, startups. When you know that you are called to help a company to build its own business, except that the business is not known. There's no clear idea about the requirements, about what they were doing, because the software you're called to write helps building the business. So you're writing something that you don't know enough about. How can you model in a fence when you don't know exactly what are you writing for? Complexity comes from essentially mixing together, connecting together relevant data. Because in the world, I still have to find a real world domain with no data, physical data to be persistently handled. So there is some relevant persistable data and tasks. And the tasks, as they are performed by users, interact, modify, read and modify data. Now, relevant data, relevant tasks, not necessarily relational tables and methods on objects, whatever. So the point of DDD is understanding the data you manipulate in reading and writing and the tasks certain categories of users are called to perform. But the common summary of domain-driven design says that essentially two things. Build an object model for the business domain and call it a domain model. Consume the domain model, an object-oriented domain model, in a layered architecture where you have 4 layers: presentation, application, domain, and infrastructure, which is just a newer version, a more modern and cool version of the classic 3-tier schema: presentation, business, and data access. The difference between the 4 layers layered architecture that domain-driven design pushes and the classic 3-tier is that the business logic has been split in 2 parts. And in this way, actually a lot of gray areas have become either white or black. I remember some 10 years ago when I started giving talks at conferences about architecture, that a common question, a common session title was how to build a business logic, business layers using ADO.NET or this or that. And a common question was, where should I put the logic that formats data to display in the user interface? Just a typical stupid question. You type an ID in a form and you want to find details about the customer or the company with that ID. Give me the code. When you call any call center, what's your customer code? And then they find out in a second everything they know about you. But the code is used to make a trivial query against a database, and a record is retrieved. But then the record has to be formatted in a nice way for the user to read it from screen. There is typically an extra step of arranging data in a nice format, in a friendly format for the user interface, where the logic necessary, the code necessary to make the arrangement goes. Is it part of the business? Is it part of the presentation? And it was a gray area. And you could hear different experts giving and argumenting, and probably with reason, completely opposite answers. Gray area. At least, domain-driven design, even the layered architecture in domain-driven design, with the 4 layers instead of 3, and splitting the business logic in 2 parts, application layer and the domain layer, made justice of this gray area. Because it says that the business logic is actually made of 2 components, 2 logical parts. The part that is application-specific, which is essentially the implementation of all use cases you implement through a UI. All the screens that you provide, that you offer to users for them to interact with the system. For each of those screens, you need to have some methods that just handle what the user do, and some methods that render the screen for the user. That is the purpose of the application layer. The application layer then orchestrates any workflow that needs to be started once the user starts a task from the user interface. Submit an order. Submitting an order starts a workflow in the real world. No matter that in some Microsoft tutorials, it just adds a record on a database. In the real world, submitting an order, checking out a shopping cart, starts a workflow of tasks. Most of the time, a distributed transaction. Everything is orchestrated from within a class, an element, a piece of software, nested in the application layer. And what is the purpose then of the domain layer? It's the invariant domain logic. Application logic is what is specific of the UI, of the presentation. Domain layer is what is invariant for the domain. So typically, if you have a website today, and then you create a mobile application to go side by side with the website, you have 2 presentations, the mobile one and the web one. So you may have, and in most cases you should have, a different set of use cases. So you probably need 2 distinct application layers. But both application layers for the mobile apps and for the website will be calling the same logic, reusing the same logic at the domain level, and the logic at the domain level just contains the implementation of tasks and business rules, whereas the application layer is how input data is provided and tasks that operate given the business rules are implemented. Anyway, in the beginning, in domain-driven design, even with the idea of building an object model and consuming a layered architecture, sounded like, well, a very cool thing to do, and not really hard to do, except that in 10 years it proved much easier to do wrong. So, more formally, there are 2 points, 2 common assumptions about domain-driven design. You have an object model, and this object model is built in a way that is absolutely agnostic of persistence. So you are allowed, you are required to have customers, invoices, orders, products, order details as classes in your all-encompassing object model, but no methods, nothing in the DLL, in the class library you create to hold the object model needs to be involved at any time with reading and writing from some sort of persistence layer. Totally agnostic of persistence. More, this object model is ideally subject to a number of, let's call them constraints. So it's required or highly recommended that in this object model you don't use primitive types. Instead of using an integer, you use a custom type that contains exactly what the integer is called to represent. What? When I say 5, 5 could be a variety of things, many things. It could be, for example, the temperature of today. Or it could be the number of goals that a football team scored against another team. Or it could be, I don't know, the size of a T-shirt, the code that represents the size of a T-shirt, the maximum number of attempts that your, I don't know, to fail logins on a website. The point of using value types in this object model is that, well, be sure that you use a proper type, okay, to represent any piece of information. If 5 represents, let's say, a temperature, a Celsius temperature, this means that you probably have an object somewhere that has a property that contains a public integer, a property to represent a temperature. But if you have on this class a current temperature property implemented as an integer, it means that that property can be set to any integer. And well, as far as I know, integers range from minus 2 billion to plus 2 billion. So does it make sense to have a 1 million Celsius temperature? Still, it's an integer. So the point is, well, create your own value type, call it a temperature. Okay, internally use an integer to store the value, or a short integer, okay, to store the value, but put around the value type all sort of controls that prohibits, makes it impossible for users of this API to set 1 million where a temperature is expected. But, yeah, okay, sounds great. Oh, yeah, good point. Fantastic. Excellent point, yeah. I love it. But in which way is this helping me? You cannot imagine how many times I've got the question, okay, I understand, I see why the DDD leads me to write cleaner code, more elegant code that I love because it's so object-oriented. But what's the point? At the end of the day, I have to write a record in a fucking database. And I can do that using entity framework, the customer object, whatever you want, or just a storage procedure. What's the point? At the end of the day, I have the job done. And if I know how to do that with storage procedures, why on earth you want me to forget my skills, which work, are appropriate for the domain and learn something completely new. What is the benefit? In terms, what's my ROI? What's my return on investment? In money terms of using domain-driven design. Of building an object model with value types, with private setters, with factories instead of constructors. This is another interesting point. When you create a new instance of an object, all programming languages, object-oriented, offer natively the constructor mechanism. You do var, whatever is the name, equals new type. The author of the class can offer multiple constructors with parameters. So you can create, in different ways, instances of a given class, specifying parameters. You can have a customer class, parameterless, which means that you get an instance of the customer that has no properties set, or you can provide in the constructor the name and the last name of the customer. So when you get the instance back for using code, you have an instance that where last name and first name are already set. Factories they do exactly the same job. They do exactly the same, except they can be given a meaningful name, because the constructor doesn't have a name. The constructor is just new customer. With a factory, you can have a customer factory dot create empty customer, or factory customer factory dot create from name and last name. Oh, I see. It's a lot more readable. Great point. Yeah, this is another fantastic point. Value types and factories. They really make my code look nicer. Thank you very much. Thanks God we have DDD. Again, what's the point? What is the ROI? At the end of the day, you have to create an instance of a class. Okay, another aspect that was another perspective that was added over the years was, look, but when you create an object model for a domain, you are actually creating an API. Good, right. Good point. So you are creating an API. And that becomes the API for that domain. That presentation layers, application layers, web, mobile, desktop, may be calling. So it's just the SDK that provides public ways to interact with the entities that make up the domain. So if I use value types, or if I use factories, I offer a more controlled programming interface to my potential clients, which could be me, my colleagues, or why not, other teams in a large enterprise scale development environment. Good points. But yet, if it's only me, if I'm the author, if my team is the author of the SDK, the API, whatever it is, and is also the unique consumer, it's me. If I know that it's an integer, and I make sure that I assign to that integer property, the temperature property, only feasible values, what is the problem? It works. If I put somewhere else in the system filters that ensure that no value gets passed to the API to store a temperature that is over 100 or 200, it's fine. So the point is business rules. Because it's a business rule that sets that particular aspect is a property, and depending on the context in which the temperature is used, it could stop at 100 or 200 or 300. If it's an industrial plant, it can, you can have a part of it where temperature of even thousands of Celsius degrees can be significant. If it's just a weather temperature, when you reach 100, well, you probably even stop at 60 or 70 or whatever is the highest temperature ever recorded on planet Earth. it's domain specific. So it's business rules and domain specific. So the point of domain-driven design starts being, understanding and rendering the business rules. And business rules and business logic is just one layer of the overall architecture. So just analyzing this constraints or qualities of features expected to be in a domain object model, you should start feeling not so comfortable with the direction, with the purpose of DDD. What's the purpose? Is helping me understanding the domain, the business logic, or building a system? To me, it's a lot more about understanding the business logic than building the whole system. And at that point, I don't need an object model to understand and connect together the various pieces of the business rules, tasks, and constraints, and users who can do what. First, I got that. And then I figured out, using my own skills in my company with the people I work with, to see what is the most effective way. And if I have to write record in a database and I have people that only know stored procedures, why not using stored procedures? But it was a nice idea. Yeah, you have an object model, completely agnostic of persistence. Okay, and what about persistence? We have beautiful ORM tools, object relational mapper tools, entity framework, and Hibernate. A lot of others, smaller, maybe more efficient, I don't know. You have the object and you delegate persistence to a separate tool. Separation of concerns. Wow! So beautiful. Yeah, it's so beautiful, but the point of the real purpose, the real gain remains. This was the position some 10 years ago. But over the years, in the first approximately 5 years of life of domain-driven design, at some point, some common questions started raising, and more people found themselves unable to manage the complexity of a single object model. Unable to manage a single object model? Oh, no, it's your fault. You're not a good architect. You need to be trained, to be educated. I have a class. It takes you 5 days of your life. It takes you a few thousand pounds. But at the end, you will be a better architect, and you will be able to manage the complexity. It's your fault. If you are not able to manage everything, if you're not a good God mode architect, it's your fault. Just pay, and you will become, all of a sudden, automatically, a better architect. But, okay, I don't see the point of objects. At the end of the day, I'm paid to write software, and if the software I have to write at the end of the day has to write records in a database, why using objects? So you don't see the point of using objects, it's your fault. You have to learn more. Gone are the days of relational tables. The future is objects and object orientation. It's your fault again. Be a better architect. Pay our courses. Spend a few $1,000s a year, and you will be better as an architect all of a sudden, overnight. Okay, this is a quote that honestly, I was really surprised when I figured out it was coming from a Microsoft person. It says, we shouldn't try to lead with a unique top-level architecture that addresses any application or subsystem. A single architecture that rules them all is not a good idea for complex enterprise software, but I would say for any software. This is a quote that comes from the foreword for the book, shameless plug, Microsoft.NET, but okay, Microsoft.NET because it was coming from Microsoft Press, so ignore Microsoft.NET, architecting applications for the enterprise. And most of the DDD ideas that I'm sharing today can be found there. And this is essentially a statement from one of the guys in Microsoft that really works with the customer and is really involved in the planning, architecture, and design of complex enterprise systems. There is a lot of truth in this sentence. A single architecture that rules them all is not good. So domain model, or at least DDD and domain model together, are again the wrong way of looking at the right thing. It's just like you have something there, and instead of looking in front, you're looking from the back. It's just a simple matter of changing the perspective of things, either rotating the subject or rotating your position around the subject. But the subject is the domain. You cannot change the domain of people. It's your position, your approach to things that should be changed. Just a simple change, switch, shift of focus. This is where you find out the real power of domain-driven design. And actually, this can be summarized by saying that at the end of the day, in domain-driven design as an approach, methodology, practice, there are two distinct parts. One is, okay, I like to use the word analytical. In the blue book, the Eric Evans' original book, this part is called something like strategic design, which makes sense. The second part is practical. So if we like the idea of using a part of DDD to build, to define and set a strategy, the second part is about tactics. A strategy is where you want to go, what you want to do. Tactics is how you do it. Concrete plans to implement your strategy. And this is absolutely the right way of looking at that. The analytical or strategic part of domain-driven design is valuable to everybody and every project, regardless of complexity. So stop thinking that the extra effort that may be required, and it is required, to build a complex, all-encompassing God mode object model pay off only in a system that has to last for 15 years, collaborative system, concurrency at all levels, enterprise scale applications. It's about analysis. You need to do good analysis, whatever piece of code, even for a stupid console application you write. There's a value, there's a benefit, because after the analysis is done correctly, you write straight, first shot, an application that is a fantastic, excellent approximation of the final product, as users really need it, and even beyond what users described. So strategic analysis is key to everybody and every project. The practical aspect, the practical segment you find in the domain-driven design description, common description, so the layered architecture and the single all-encompassing object model, that's good. It's still a good way to implement some things, but it's just one of many other possible recommended supporting architectures. Okay, so guess what comes now? Let's focus on the strategic part, analytical part of domain-driven design and explore the key patterns, the key practices that you can do and you should do every day to come to see, to let emerge out of requirements and interviews with users the real system that is hidden behind the Word documents and the words and the recorded interviews. Conducting analysis using domain-driven design essentially consists in defining a ubiquitous language. A ubiquitous language is nothing more than a plain glossary of terms, nouns, verbs, even adjectives, even adverbs in some cases, that form a language, a glossary, to be used in all forms of spoken and written communication by all parties involved. Now, I mentioned the shift of focus that takes you to consider the real value of domain-driven design. In the Blue Book of Eric Evans, in the original Blue Book, there is a huge part on ubiquitous language, a huge part on what comes next, bounded context and context maps. But those parts are in the second half of the book. So the message is build an object model, and then when you build the object model, be sure that you can see out of that a ubiquitous language and split the model in smaller pieces in bounded context. It's the other way around. Define the ubiquitous language first, so that you see which are the relevant terms and tasks and actions and users acting in the domain for which you are writing software. Identify bounded context, so where it's good to split subsystems. And when you have a map of subsystems and tasks, you reason about how to implement them, and at that point, building an object model is probably just one of many other possible approaches, but there is nothing to be ashamed of if at some point you decide to implement a part using a CMS, using CRM, using a SharePoint infrastructure, or maybe just a plain stupid client-server, ADO.NET based database. Bounded context is another key concept, and it identifies an area of the domain that is better treated separately as a distinct subsystem. Totally, unrelated from others, but able to communicate with others. Shaping a bounded context is the challenge we face. Why we need a ubiquitous language? Why it's so crucial to have one? People use a business-specific lingo. This happens in every company. If you are a corporate developer, you know the lingo, the jargon being used in your company. And sometimes if you work for a large enough company with multiple departments, you find out that the same term doesn't mean exactly the same thing in different departments. And if you are instead a developer and you work for a consulting company, it means that you potentially face in the course of your career completely different business domains. You may work for an insurance company. You can have an insurance company as a customer one day, a bank another day, an industry yet another day. And they are even different banks or different insurance companies, even though the domain is roughly the same, but the context is maybe different. And in all these scenarios, there's a different customer-specific language. So, domain experts, so people who live and actual users of your system speak a language. You as a developer, an architect, a software professional, tend to speak another language. Maybe sometimes we say the same things, but just use different words. I was a very young boy when I think it was my second job, for one of the worldwide huge, humongous consulting companies. The first week there, they trained us and just to try to demonstrate what would have been the typical week at work on a customer site. And they wanted the group to produce a report at the end of the week, so they had us doing some work for the week, and then the Friday, we were expected to report to a fake customer. So a manager came, and he played the role of the customer, and one of us was the spokesperson for the group, responsible for presenting an offer or project, whatever. And okay, I was voted to be the speaker. And at some point during my presentation, I used the word, we save this to a database. What? We save the information that you use, blah, 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 blah. We save that to a database. What's a database? Come on. I mean, we are a consulting company. What's a database? I mean, I was 20-something. A database? No, I'm a manager. I'm the IT blah, 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 blah. I'm the chief whatever. I'm not expected to know what a database is. So change your language. So I got my first exposure to the problem of a language. So we developers, we technical people, tended to use terms that actually are absolutely, obvious in their meaning, unambiguous in their meaning to us, to the group of us. But they mean just nothing to people outside the world. And then there is the psychology of persons that comes into play, because there are people who are not afraid to say, what the is the word you used? Database or the other way around? Say account. What do you mean by account? And there are people on both sides, on both parties, developers and domain experts, who are afraid to ask, and they just make assumptions. Okay, he said database. It should be, okay, my son told me use this word probably last week and email. Okay, you build, you assume it means something. And sometimes what your assumption is not completely correct or totally wrong, and vice versa. So if as a developer, you misunderstand a business term, you end up building a part of a system on wrong assumptions. When you deliver, even if you are agile and you deliver in 2 weeks something, 2 weeks later, you are likely to rebuild from scratch because you got it wrong. Oh, we call, users change the requirements. No, it's you, me, us, who got it wrong the first time. Sometimes users just change their mind, okay. But most of the extra churn, the requirements churn, most of this is due to our misunderstanding, bad assumptions we build because we don't always use an effective, ubiquitous language. The primary goal and the number one return on investment for a ubiquitous language is help making sense of user requirements, mitigating the risks of misunderstanding and avoiding translations between distinct jargons. This is not a secondary point. Imagine that the system is in production, and at some point there's a bug or there's a misbehavior. So you got a call from the customer, and the customer tries to explain what it thinks is wrong in the system. But what the customer observes is the final effect, the wrong number on the screen. And it tells you about that. But to figure out what could have caused the misbehavior, you need a lot more technical detailed information, right? And this is a drama. I think everybody here has countless experiences like this. So talking to a customer, and okay, but no, and they tell you a lot of details that are totally useless. And they don't give you what you really need. And if you stop them and ask a question, they don't know the answer. Because maybe they don't understand you. They are not able to, look into a database or test when they last time logged in or whatever it is. So there's also two people talking. The first times I came to UK or United States 15 years ago, well, I was more or less able to speak English, but the first time I had a talk in English, TACAD 2009, TACAD in 1999, one of the feedback modules contained, next one, get one who speaks English. So it was, okay, we were talking about, databases, OLEDB, whatever it is. So in the room, there were a group of people with some shared kernel of a language, but I was speaking, well, mostly Italian or in English, which was essentially dialects of Italian, and everybody else in the room were from UK, from the Netherlands, who were speaking English much better than me. But even the few in the room who were from, I don't know, China or India, who were not speaking a better English than me, they were still unable to get the few common words that we were saying that we know each other. So communication is a tremendous point, a critical point, that ubiquitous language, which is not a silver bullet, but helps immensely to smooth. So once defined, the ubiquitous language, which is essentially a glossary, nothing more than a glossary of terms, this means that, this means that, this means that. Building the glossary is no big deal. It just requires attention and commitment. It's more challenging to force yourself to always use the language in any communication, written and voice, within the project. So when you write an email, when you text someone, when you write a WhatsApp message, when you write a document, when you talk, whatever public piece of documentation, except email exchanges within the team or within domain experts, every cross-group form of communication should be strictly based on ubiquitous language. Is more, if you have ever worked on an international team, I was in the speaker's room, and there were a group of 4 people from Israel, and they were sitting one close to the other. They were talking with themselves. At some point, they switched from English to Hebrew. It makes sense. I mean, I do the same when I'm at a conference or a customer, and there's an Italian guy, and we're talking to each other. Okay, we are in an English-speaking context, but we are talking, me and you, why not speaking? We have a different first language, why not using that? But every if I'm talking to another Italian, but in the context of a wider conversation, we speak English. That's precisely what should happen when using a ubiquitous language in a project. The language is not artificial. So there is no wizard, no scientist no doctor who wears a white coat that gets to the office one day and says, okay, today I created the ubiquitous language for this project. We have to start up the project. Okay, I created the glossary. No, it doesn't work this way. It's a language that grows up, emerges from interviews, from discussing requirements. So you start projects the same way as you do today, processing, doing whatever you do to process user requirements. Except that your primary point should not be, figure out what the user is asking and mapping that into a technical solution, but just understand the mechanics of things. Flow charts. When I started learning programming in 83 actually, the first thing they taught us was flow charts to define the algorithm. Okay, we wrote an algorithm flow charts for calculating the factorial or maybe to some numbers in VIC-20 basic language of 35 years ago. Today, in a much more sophisticated scenario, but it's the same. It's the language of flow charts, it's the language of business, it's the language of entities and what each entity can do and which properties, which attributes it has. And how each action impacts on other entities, which events are generated, which within the system and outside the system. It's about understanding the business domain. And in doing so, actions, names, entities, tasks should be given a name, and that has to be the name. At the same time, the language should be essentially inspired by the real language being spoken by people in that business, in that company, but it has to be kind of formal. So ambiguity should be removed. And as an architect, you have the responsibility of, yelling out when you seem to find that two words are having the same meaning or double meanings is associated with the same word. Be sure you can identify and resolve any ambiguity. The final language should be unambiguous and fluent. Fluent that you can easily model in terms of methods on classes or whatever is the paradigm, the programming paradigm you use. In terms of, for example, functions, if you use a functional approach. So, technical and domain expert expectations should be matched. More importantly, all relevant business terms defined within the ubiquitous language should have the right meaning. If a word is critical, if it's critical business-wise, there should be absolutely no ambiguity on what it means. Concretely, it's a glossary, so you can save it to an Excel file, or a Visio diagram, or a PowerPoint, Word document, whatever you want. It's just a database, whatever you want. It's just a glossary of terms that should be saved and made available in some way. Keep it up to date, because it's not a static language. It evolves. It evolves as the business evolves, as the definition of the business evolves, and as the understanding of the business evolves. It happened to me so many times to have what I considered a defined language, a defined accepted terminology, and then, writing software, I said, well, but I can probably find a better name for this. And, or maybe talking to customers, I figured out that, well, I'm using this term, okay, it's probably not enough ambiguous now, but it's ambiguous enough to deserve a better name. So it's about continuous refactoring of code, continuous renaming of namespaces, classes, and methods. So another thing that concretely you need, another tool you concretely need, and sorry for another shameless plug, is a tool that helps you when you write code to do quickly and reliably renaming. This is where I fell in love with ReSharper. Because with ReSharper, you do that, renaming across projects and solutions in 3 clicks. And it's reliable. But also architecture tools in Visual Studio, also the capabilities, analogous, you find it natively in Visual Studio, and even more, I think, in the next Visual Studio, which is essentially ReSharper, as it is today, right in the box. These are tools that you should become very, very familiar because it's a matter of survival. Keep it up to date, and the ubiquitous language should emerge from code. So the code class names should be one-to-one with names, actions, elements in the ubiquitous language. There should be a one-to-one total, full correspondence between names in the ubiquitous language and names in classes. Otherwise, it doesn't work. So if you are talking about, an e-commerce application, and at some point we are focusing on the task of canceling an order, everything should be named using the term cancel the order, not delete the order or delete the record, even worse. Even though at the end of the day we physically delete a record from a database, but unless it's a private method, an internal implementation detail, the public name should be cancel the order. Because when the customer complains that an order was not canceled or the cancellation was treated in a bad way, it tells you, well, when I try to cancel the order, and if that is the language you know, you immediately are focused on what is the area of the code that you should look into. So you don't have to make the additional translation, okay, cancel the order, but what it is? Okay, I delete the record, so I have to look into a storage procedure or using the ubiquitous language in code. Okay, the language is critical, crucial when there is a lot of domain logic to deal with, so complex systems, and when the logic is not completely clear because the business is young and not completely defined, and the software is part of the building of the business, and startups here are the classic example. So concretely, if you have a user story like this, has a registered customer of the blah, 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 I can redeem a voucher for an order I place so that I don't pay actually myself for the items I order. From this user story, you identify that registered customer is a term that the language, that the business uses, that the voucher is the name they use to identify a prepaid token that can be used for buying things. In the world, we can find several synonyms for voucher. We can call it a coupon, we can call it a gift card. But the business there uses the term voucher, and this is the official name for any prepaid token being used there. And if you happen to talk to other departments in the same company and they use a coupon, you have two problems. Either you have to ask why they're using different terms, but if the other group uses coupon and doesn't intend to change that because it's part of their culture, you are going to have a separate, ubiquitous language. Don't mix the things together. And here you see that a voucher is an entity in the domain, and redeem is an action that you can, in that specific context, perform on a voucher. So at some point, either on the voucher class, on a service that manages the voucher, there should be a method called redeem that is invoked to start the process that actually redeems a voucher against the payment of some goods being bought. Now, 5 seconds ago, I said that, okay, what if another department, another group within the same company, same organization, uses coupon instead of voucher? What should you do? This is precisely where the concept of a bounded context fits in. In the beginning, so when you start processing requirements, you assume, and that's absolutely normal, that there is one business domain, indivisible. And you aim at building a single ubiquitous language for the single domain. But as you proceed, as you learn, as you process, as you interview people, as you talk, as you discover more and more about the domain, it may be that at some point the same term gets different meanings, or two terms different are used to indicate the same thing. This is an ambiguity. Now, there are ambiguities that can be resolved by forcing people to use the same term. But sometimes this is not possible, and in general this is not possible, or it's preferable not to make it possible to avoid confusion, when there are sort of physical boundaries between people. So different departments, for example, or different offices, or different group of people having a slightly different perspective of the business. So when this happens, and of course also based on the number of potential ambiguities you find out, you may decide that you crossed the invisible boundary of another bounded context. So a bounded context is nothing more than a subdomain. So splitting the original big thing in smaller pieces. It's up to you to decide where you put the border. But some border should be put at some point. And typically, when you find unsolvable ambiguities on terms, that is an excellent signal that you probably are close to the border of a bounded context. So you split the domain in distinct bounded contexts. Each bounded context is a domain. It's a smaller piece. It should be treated iteratively as a domain, except that it's smaller. More formally, a bounded context is a logical area of the application domain that has its own ubiquitous language. It has its own independent software implementation, which means it can have a totally distinct architecture from other bounded contexts. So one could be SharePoint, one could be a CMS, one could be, a Python website. One could be an ASP.NET Classic website, or a Windows service, or whatever it is, a Node.js server, whatever. And third, an interface to talk to other bounded contexts. Because, we treat the bounded context as a separate, distinct entity from the perspective of the language and the perspective of the architecture and implementation, but they are part of the same domain. They are subdomains of a larger domain. So, at some point, they need to communicate. Maybe not every bounded context should communicate to all the others, but it's reasonable to expect that two bounded contexts should communicate at some point. So an interface to talk to the outside world is required. But again, even in this case, it's up to you. How you do that is an implementation detail. Not because of this. It has to be a SOA web service. Not because of this, it has to be a microservice, whatever that means. Not because of this, it has to be a standalone website. Just a mechanism, a software mechanism that enables two contexts to share and pass each other information. It could be a shared database, for example. Or maybe in some other cases, a message queue. Or just an in-memory, implement two classes implementing an interface, so in-memory communication. It depends on the implementation, the architecture, the overall context. The overall context. So, in light of this, we could say that a system results from the composition of multiple contexts interconnected via a context map. When we split the big domain, we have several balloons. Some of these balloons are connected. Each balloon is connected typically to at least another one, but we are in the same planet, in the same larger domain. So what we have is essentially a graph. The technical term is a context map. And as an example, we can have, in an e-commerce scenario, one balloon, one subdomain, one bounded context to be the web store, another one, the part that takes care of the accountability, another one is delivery and shipment, another one could be any external service for example, delivery and shipment, or maybe for currency, in an international scenario, currency rates, or maybe another bounded context is when you have legacy code to integrate. It's code that it's there, it works, exists, you don't want to touch it, put in a sort of a black box and let it communicate safely with the outside world. Treat it independently, not because you have a legacy code written with a technology you don't use in other parts, you have to mix things together. Yeah, this is the point. Legacy code is bounded contexts are also a fantastic way to concretely work and deal with legacy code. Each context has an independent implementation. So concretely, imagine this is the original, graph of classes, entities, and relationships you figured out. You can have different teams of people also to work on different parts of the model, each with its own area of influence, but sometimes it happens that there is some overlapping. And the overlapping here puts the integrity of the model at risk because, okay, these two terms should be, these two entities should be treated differently by each teams. And they could have a different public interface to 1 and 2, and different methods for 1 and 2. Or maybe even when the same property is defined, assuming these are classes, not necessarily the same property is an integer to one team and is a string to another one. So when there are shared terms, it could be that they are not exactly the same thing. So what you can do to resolve the overlapping issue here, you can consider them to be distinct bounded contexts. So each development team, each group of work has its own copy of those entities. Maybe the same name, but the behavior specific of this programming scenario. And the same here. If this two needs to communicate, okay, they define as and it's an implementation detail, some sort of API, whatever, from buses to message queues to in-memory communication to shared databases to talk to the outside world. In general, the number and also the relationships between a bounded context reflect the physical organization, the physical structure of the organization, so departments, offices. Overlapping is quite natural, so don't be afraid if you detect overlapping. It's not you, it's the business. And, okay, redundancy and duplication, so to speak, so because bounded contexts sometimes are about duplication, or what we perceive as developers coming from 30 years of relational modeling, redundancy, duplication, ooh, it's a physical pain, but it's a key aspect of modern software. Use the things, use the information, do the things for the specific purpose. And don't ensure that information can be kept eventually in sync, but focus on the actual tasks. There are a bunch of patterns, weird names related to architecture, things like event sourcing, CQRS, that you may have heard. But the fundamental point of these architectural patterns is that they try to guide you to obtain and build exactly what you need, regardless of certain constraints, and redundancy is one of those, one of this. In particular, a typical CQRS architecture, there are so many flavors of CQRS architectures, but one is that you write, the user does an action, you write, go through a pipeline, go down to the persistence, you write, and then the action ends there. There is an internal part of the system that asynchronously updates another database, parallel snapshot database, for queries to read from there. A scenario could be you save a document, you save an event, what has happened? An invoice has been created, an invoice has been updated, an existing invoice has been updated. So you only save the delta, but then after having done that, you update asynchronously server-side another database, which is a plain SQL Server table, where you read the snapshot, the current status of the invoice. So in this case, you have the list of events, the story of the object, and the current snapshot state. Distinct databases. Oh, there's duplication. Yes, there is. But that helps you to keep separated the command and the query stack, which is the point of CQRS. But there is duplication and redundancy. Yes, there is. There is eventual synchrony. Yes, there is. but for most modern systems, for every system, it works. So there are several pillars of software development and modeling that we have learned or just inherited from people, from teachers, instructors, former colleagues that are going to be reformulated these days. Okay, to finish off, context mapping. So let's say that once you have identified bounded context, you end up having blocks, balloons like this. There is the core domain, the back office, weather forecasts, which is an external service, club site. I'm trying to imagine here a website for a booking website. Okay, and there might be some relationships between these bounded contexts. Now, the nodes, if we consider this as a graph, the nodes on the graph are bounded contexts. The arcs connecting graphs are put there by the architect that, in a way, envision the relationships between the code and the tasks being performed, the functionalities being provided by each bounded context, and it determines the priority or the order in which communication will take place. So this is the point of the U and the Ds that you see on the diagram. U indicates upstream. So the core domain in this diagram is an upstream context. Back office is a downstream context. And it's, as you can guess, upstream and downstream indicate that the upstream context is more important than the downstream context. So between the two, there is a master-slave type of relationship. But in domain-driven design, between upstream and downstream context, there might be two possible types of relationships. So master-slave is not a DDD terminology, but it gives the idea of what it means. So there's a master and there's a slave. But the technical aspects of this master-slave relationship can take two forms: the conformist relationship and the customer-supplier relationship. And these are DDD-specific terms. The conformist, both are master-slave types of relationships. So the conformist relationship means that the upstream just doesn't see, has no idea that there is a downstream context. So from the downstream perspective, the code being created by the upstream context is something I can only consume, I have no control over. I have no room also to negotiate changes with them. Typically, it's a legacy code or an external service that I consume, an external API that I license, but it's there. If they change something, it's me, okay, to just adapt my code to those possible changes. And to minimize the impact on my infrastructure of a conformist relationship, I can create an anti-corruption layer, which is an extension to the context that essentially acts as a proxy and offers to the bounded context a constant and fixed interface, a facade, okay, while absorbing the interface details of the outside component. The customer supplier instead is also another master-slave kind of relationship, but there is here some limited room for negotiation. So at least you know who owns the upstream context. That context remains primary, but in case of need, of urgent needs, you can go and expect that the team at least listens to you and takes into account your concerns and is potentially open to make changes to accommodate your needs. If this doesn't happen, customer-supplier turns into a conformist relationship. So the difference is essentially the room you have, the margin you have for negotiating changes, which is 0 in conformist, greater than 0 in customer-supplier. The partner relationship, instead, is when it's 50-50. The two teams, the two contexts, work together at the same level of importance, of relevance, same priority. So this team cannot make changes, or at least to the public interface of changes that can affect the other without first talking to a club site and vice versa. So they work together to deliver a commonly shared piece of functionality. These are the relationships that you can have on the bounded context graph. And once you have this kind of graph, the next step is, what do you do next? You validate the context map as an architect. Okay, this is it. I think that this map, with this bounded context, this represents exactly the domain that the customer, we understood from the customer descriptions. Now, you focus on each bounded context separately. Concrete design. Each bounded context gets its own design. And, okay, you're an expert architect, so as you learn what are the functions expected to be offered by bounded context, that is enough for you to start forming in your mind an idea of what could be the technologies, the architectures, if it's a layered architecture with object orientation, if it's better functional, and you come to these conclusions also in light of the people you work with, the skills you have there. But actually, as an example, consider that some time ago I worked on, I provided architectural consultancy to a company, and they sell really mission-critical software, essentially monitoring systems for industrial, typically power plants, photovoltaic, and similar. So wind farms, these kind of things. And so customers are companies like Gazprom or Electricité de France, so huge company-wide companies. Anyway, at some point, we were discussing what was the most effective way to save information coming asynchronously into the system from physical sensors connected to elements in wind farms or photovoltaic plants. In theory, we could have used MongoDB or RavenDB, a NoSQL, a document database, because each incoming signal could be significantly different from others, so we had a lot of differently shaped records, hard to fit into a regular SQL Server database. And if you had to use SQL Server databases, it would have ended up being a database with maybe 400 or 500 columns, which poses a significant performance issue. So we had technical reasons for not using SQL Server, but we ended up using SQL Server because the lead architect first asked me to produce documentation and analysis on both options. And then he had to make a decision. And he decided that given the existing skills in the company, and in light of the possibility of retraining the IT department to provide support to customers, they know everything about SQL Server. They are familiar with a huge ecosystem of tools around the SQL Server. They can detect performance leaks, bugs, or this or that quite quickly. Retraining these people to use MongoDB or RavenDB or whatever else, well, it's in first place a cost for the company, and instead of gaining a benefit, we risk to have to offer a support service, a customer care service, worse, because it takes years to these people to build the same familiarity with the tools. And add to that, that the level of tools and the number of tools existing for non-relational databases compared to relational databases is like 1 to 100. So all considered, the architect said, well, we'll find out, we have to work out a way to improve as much as possible the performance of SQL Server with 500 columns, but we're going to go with SQL Server, even though we had technical reasons for not using SQL Server. Another point in an analogous context could be the cost of licenses, which are significantly lower with NoSQL. So this is to say that the architect picks up what he considers the right architecture and right set of technologies, looking at all parameters, including skills, including constraints, including budget. Now, not because we have a graph with nodes, we are talking about anything like service-oriented architecture. So it could be that each of these blocks ends up being a separate, standalone module using HTTP or TCP or I don't know what to communicate. It could be, but I mean, not necessarily. It could even be that, for example, okay, this is a possibility, but it's not necessarily the way to go. It could even be that some of this, the back office, for example, is a separate website, adminmycompany.com. Or maybe the weather forecasts is a standalone service that I subscribe to, but I don't control. But the core domain and the club site, they could be just a single website, plain MVC, ASP.NET website, in which maybe these are simply two distinct class libraries. So a bounded context not necessarily is a tier, is a separate, autonomous, SOA-style component. It is just a piece of code, a piece of functionality in the business domain you treat as a standalone module. And you give that the best architecture. So, I mean, in this example, back office here and club site, this happened to me recently. We had different people working on. These were both ASP.NET websites, distinct, okay? This was written using web forms because the people there were highly skilled in web forms, and this was essentially a crude system. So with data grids, we could have it done in really quickly. This was a more sophisticated kind of website, and it was written using MVC, using CQRS, using event sourcing, blah, blah, blah. Still in the same Visual Studio solution. Okay? Now, final slide. In summary, bounded contexts have there are a number of supporting architectures. So supporting architecture is an architecture that you can use to implement a bounded context. You can use anything like a client-server, two-layer or two-tiers architecture. If it works, fine. So don't be afraid of doing that if it works. You can use multi-layered, 3-4 layers architectures. In the business logic, to implement the business logic, you can use the domain model pattern And the domain model pattern is now domain model as defined by Martin Fowler, which is a web of interconnected objects. But the domain model can also be a list of functions if you like going functional. But it's a way to express the business logic, essentially. But there's nothing bad in implementing the business logic using components and moving data transfer objects, I think what is called the anemic domain model. It's all about, it's not a matter of religion, of going with objects because it's cool, it's a matter of being effective. And you can find that sometimes using objects is really effective. In other scenarios, using a functional approach is even better. CQRS, it doesn't exclude the domain model. CQRS is simply an architecture that says, treat the pipeline of commands and queries separately. So you have yet another level of splitting. Bounded context is one level of splitting. In each bounded context, you can have a segment to take care of commands, so tasks that alter the system state, and a separate set of components to read from the existing state. And they may not even be sharing the same database. And you do that, you use multiple databases, in this case, kept in sync automatically, if you want to scale or to improve the scale and treat systems, read and write separately, to optimize each individually. And then CQRS can also be topped with events, so with event stores, so databases, even a relational database that saves events as they are detected, and then uses logic like replaying events to rebuild the state of the system. But in this case, you don't miss anything of the events in the system. It may or may not be useful, depends on the context. But this is essentially a comprehensive list to date of the supporting architectures you want to consider for building a bounded context. And even if you use an old-fashioned ADO.NET style data grid data binding, you are still doing domain-driven design. Thanks for your time. I think I can extend this concept to say the best we know today, the cutting-edge approach we know today, to approach development of software in a way that at the end of the pipeline turns out to be effective. Domain-driven design is not something new. It's something that has been around, maybe ignored, but it's been around for about a decade. And over 10 years, the world in general and the world of software development has changed significantly. And probably we are only halfway in a process that will take the world to be deeply dependent on software in the years to come, even more than it is today. So essentially, many of us, at least those who have some 50 shades of gray hairs on head, we know, we may remember that in the 90s, 15, 20 years ago, it was all about having a strong, powerful machine, that server, the mythical server machine, to host a database, a powerful relational database, and everything else was a detail. Once you had a strong relational model, compliant with the first, the second, and the third normal form, with no redundancy at all, because you don't want to have redundancy, with all the relationships and constraints properly set, you were pretty much done. Everything else was a detail. You need logic, business logic, to deal with cascading updates and cascading deletions. Fine. You had storage procedures right in the database. Your company invested a lot of money to buy the database server, so most of the work must be done. I want to take advantage of that. I paid my own money, so is that if you today Google for domain-driven design, most of the information you find pushes an idea that doing domain-driven design is essentially building an object-oriented model, where instead of using data sets, record sets, or record-related classes, you have objects instead of the customer table and something that allows you to read and write from a customer table. You have a customer class in C#, and this customer class offers properties, no properties, read-only properties, and no setters, just methods, because you have to reflect the behavior of the customer. This is the number one misconception. The real power of domain-driven design is elsewhere. And the object-oriented domain model to represent through interrelated objects the behavior of the system, that is just one possible way of implementing the results of the analysis. So the expression domain model that I'll be using quite a bit of times today, and it's the primary expression in any DDD document. Domain model should be intended as a model, a software model for the domain. So the primary misconception is associating the term, the expression domain model with a pattern or something more specific like an object-oriented model. A domain model is simply a software model for the domain. So the collection of entities, the collection of tasks. Welcome, everybody. My name is Dino Esposito. We talk about domain-driven design. Just a few moments ago, just before getting into the room and getting ready for the session, I checked TweetDeck, and in my stream, there was a friend of mine doing another conference in another country, and he just posted a picture of the room, of a crowded room, saying, well, there's a lot of people, there's an overflow of people willing to learn about ASP.NET, what's the next version, 5, 6, 7, whatever. The newest, wave of tools and frameworks and releases coming from Microsoft. Frankly, I'm a lot more proud of this room. Not because of you, but because the number of people you are. Domain-driven design is, humble opinion. Okay, I'm presenting about domain-driven design, but I'm writing software for the real world. And even though I don't work in large-scale enterprise applications, I work in a scenario where software has to be not particularly complex, but highly performant. And right to the point, straight to the point, because how people, operators, users, and not necessarily super smart people, engineers, normal people, has to work with that software and has to work effectively for the business, the underlying business, to run and produce money for everybody to enjoy. Domain-driven design is the best practice, methodology, approach, pick the word you like most, that I know, but the database has to work, not the developers. Over the years, the complexity of the logic, but also the need to, the business need of implementing more sophisticated business rules than those you could handle with TSQL in a storage procedure context, started, putting more and more tiers or layers of code on top of the database server up to building what we call today layered systems, multi-tier, multi-layer system with presentation, business, various levels of business, data access layer, and so forth. But yet, the approach, the natural, native, built-in approach that most architects use to plan software today is the approach that we inherited, maybe through education, from what was the standard 20 years ago, starting from bottom and going up. Domain-driven design played a role at first in encouraging and even strengthening this approach. So this talk is about the good and bad of domain-driven design. And more importantly, this talk will try to clear up some things that I call misconceptions. So things that you just should consider the other way around. So essentially, the same author of the inventor of the domain-driven design approach, methodology, practice, Eric Evans, he wrote a book about 10 years ago, and with that book, domain-driven design started to conquer the world. But, and this is a specific event, an anecdote that everybody knows. A little less known anecdote that still involves directly Eric Evans happened 5 years later, 2009, QCon conference, I think it was March 2009, here in London. You can still find on YouTube the video of the talk that Eric Evans gave at QCon London 2009, where essentially he said, what I have learned about DDD in 5 years. 5 years elapsed from the release of the book up to 2009. And in that talk, he essentially lays the ground for the things I call misconceptions today. So the same author observed a sort of turnaround of the perspective of domain-driven design. And the point is that today, that domain-driven design is necessary, is a strict requirement, but not because the software you write, but because it's fundamental to understand, deeply understand the business domain and what are the processes that exist in that context in the real world, and the software is there just to mirror those processes the best and the most faithful possible way. If we fail on this, if we introduce deliberately approximation, a gap, we are going to pay more and more in terms of loss of business or extra costs of maintenance, just this gap that sometimes, if we do, well, sometimes, I would say always, if we put enough effort in the preliminary analysis, we can actually spend, probably more time up front, but we save a lot money, time, and budget in the rest of the software life, and we save in terms of maintenance, in save of changes of requests, in terms of misunderstandings. So, the fundamental takeaway from this hour and a half, so the primary misconception I want to make sure that you grab and take with you when you go back to the office,